Alright guys, so I'm back with part 2 of the triangle sum theorem and exterior angles theorem problems. We're going to cover problems numbers 9, 10, 11, 14, and number 5 on the more practice problems or worksheets. Oh, sorry, we're going to do 7 as well. These down here, numbers 8 through 12, they're more word problems. You'll get more practice with those in class. And I think it's better off that we cover those in class together anyway, so let's just get down to these. Now, number 9, look at the given information. It said that line L is parallel to line M. We already know. We got some parallel lines. There's some properties, happening here with these angles, okay? There's a lot of angles. There's a triangle in between them. What's going on? Well, let's take a look at some of the relationships, and I want to first take a look at angle 1 and angle 73. Also, I'm going to put the little notation here that they're parallel because they forgot to do so, so I just want to be consistent with what you already know. Okay, so if you look at angle 1 and angle 73, what do you know? Well, they're both between two parallel lines. Between, what word comes to mind? Interior. Okay, so angle 1 and angle 73 degrees, that angle, they're interior. And if you look at this line right here, let me highlight this. If you look at this line right here, are these angles, or this is the question you should ask yourself, are these angles on the same side of that line or the alternate side of that line? Okay, so what am I alluding to? I'm alluding to some transversal parallel line problems. Well, you see very clearly that they're on opposite sides of this transversal. So angle 1 and angle 73, angle 1 and the 73 degrees are alternate interior angles, right? And what do we know about alternate interior angles that are between parallel lines? We know that they are congruent. So the measure of angle 1 will equal 73 degrees. That's how we get that. Okay. Now that might not be the easiest one to start off with. In all honesty, probably angle 3 is the easiest one to start off with because we know that forms a linear pair with the 73 degrees. Since we know they form a linear pair, we know that they're going to add up to 180. Let me get my calculator. 180 minus 73 degrees, that is 107 degrees for the measure of angle 3. Okay. Let's take a look at number 2, angle 2. Well, angle 2 is a part of this triplet up here. Okay, hopefully you can see it. I'll highlight it if you can't. But it's part of this angle 1, 49 degrees, angle 2 triplet, right? And what do? They form line L. So what do they add up to? 1, 2, and 49. They're going to add up to 180 degrees. Well, I already know that the measure of angle 1 is 73. Don't know what the measure of angle 2 will be, and then I know I got that 49 degrees right there. We know that's going to equal 180 degrees. Let's just, do some rearranging. 73 plus 49, that's 122. Therefore, the measure of angle 2 will equal 58 degrees. Okay. All right, so we are more than halfway done. Let me just write in some of these angle measurements, okay? Let me do this with a different color, and I'm going to do a different pen size as well. This is 73 degrees. Angle 3 is 107 degrees. And angle 2 is 58 degrees. So this helps us with angle 4 because angle 4 is created right here. And we already know that these two angles right here, the 73 degrees and the 58 degrees, they are going to add together with the angle 4 to get 180. But let me take a step back, actually. Let's actually solve number 5 first. Mostly because I want to reinforce what concept? Exterior angles theorem, right? Angle 5, this guy, he's on the outside of the triangle. What are his non-adjacent angles? The 58 and the 73. Right? So we know that the measure of angle 5 will equal the sum of its non-adjacent interior angles. And we get 131 degrees. Okay? Measure of angle 5 is 131 degrees. And this makes solving for angle 4 actually a lot easier and a lot less space to do this problem. I'm actually going to do it above the problem. If we know that angle 4 and angle 5 are in a linear pair. So the measure of angle 4 is equal to 180 minus 131. That's 49 degrees. There we go. It looked very challenging, but, you know, with some time, we got it done. Let's look at 10. 10. Well, we got this big, well, look, all the angles in here are 90 degrees. Now, these sides don't look congruent to one another, so we can go ahead and just say that this is a rectangle, okay? This is a rectangle. All the interior angles are 90 degrees. But we got a lot of angles to solve for. We got 6, okay? So let's inspect real close which one is probably easiest to start with. If we look at this top triangle, we know literally none of those angles inside, okay? We know that we have these little segments right here. Sorry for the screaming children in the background. But we don't know if those are bisectors. So we don't know if those angles are going to be 45 degrees. So we can't assume anything. So I wouldn't start with that triangle. If you look to the left-hand side, we have this angle, right? We don't know what this is, and we don't know what that is. And we don't know if this is a bisector. Actually, you can pretty much tell it's not a bisector because this is 52 degrees, right? However, this one would be pretty easy to solve for, but I will tell you that me going to solve this as a student myself, I would tackle the biggest triangle in here with that 52 degrees and that 90 degrees because angle 3 up here, there's only one thing that could be, right? 90 degrees plus the 52 degrees plus the measure of angle 3, that's going to equal 180. 90 plus 52, that's 142 degrees. Measure of angle 3 is equal to 180 minus 142, 38 degrees. Okay? It's going to make my life a lot easier. Okay. Let's solve for some other ones like angle 6, okay? We know that this is a right angle. There's no denying that. So if this angle is 52, then this angle must be 38 degrees, okay? It must be. Oh, actually, we saw that angle 3 was 38 degrees as well. So what does that say? Well, you know, they're on opposite sides of a transversal. That must mean the two lines, this one up here and this one up here, must be parallel. So just as we predicted, this is a rectangle, okay? So, good for us. All right, just so you know, the reason why I got that this is 38 degrees is because this whole thing is 90. And although this is not a bisector, this angle or this segment right here, we do know that these two will have to add up to 90 for this to work. All right. So now angle 5 becomes a lot easier for us to solve because we have 38 degrees and 86 degrees. So let's actually draw that out. We know the measure of angle 5 plus the 38 degrees plus the 86 degrees will equal 180 degrees. .38 plus 86. Whoops. 38 plus 86. It's 124. Therefore, the measure of angle 5 has to equal 180 minus 124. That is 56 degrees. All right. So we got, we got angle 6 as well. That's 38 degrees. All right. So all that's left to do is find all these angles up here in the up top triangle, and now it becomes a lot easier. All right. For example, I'm going to change my pen color. For example, we know that angle 4 and 86 degrees, they form a linear pair, so they have to add up to 180 degrees. So angle 4 is 94 degrees. So what type of triangle is that? That's an obtuse triangle up there because it has one obtuse angle. All right. We also know that angle 5 and angle 1, they form that 90-degree pair as well. So if angle 5 is 56, then the measure of angle 1 has to be 90 minus 56 to get us 34 degrees. And then finally, you can go about finding angle 2 in a similar way. And actually, we already established, because these two are congruent right here, these two angles, then this angle right here, angle 2, will be congruent to this one down here, which is 52 degrees. So you just got to use your knowledge, your previous knowledge, if you want to work it faster. If not, you can, by all means, just add everything up that you want to do. All right, let's move on to 11. Okay. Right off the back, I can already tell that we have some relationships in here, such as the measure of angle 2 and the 71 degrees, they're vertical, right? So the measure of angle 2, that's going to be 71 degrees. What else do I know? I got some parallel lines. Let me highlight them for you. And let me highlight those transversals in a different color. So I already know some things. If this is 47 degrees, this one right here, then this one down here, which is angle 7, that also needs to be 47 degrees. What else do I know? I also know that if this is 71 degrees right here, then the measure of angle 3 plus that 71 degrees is equal to 180. If you hear that scratching noise in the background, that's my cat scratching to come outside. 180 minus that 71, that's going to get me 109 degrees. So the measure of angle 3 is 109. And the measure of angle 5 will also be 109, based solely on the fact that they are vertical to each other, right? Measure of angle 3 and measure of angle 5, they're vertical. You see how many arcs I'm doing? That's to show the congruence, right? That's 3 arcs, that's 3 arcs. They're congruent to each other. So what do I know so far? I know this one, I know 3, I know 5, I know 7. So I'm left with finding measure of angle 1, 4, 6, and 8. And those can all be solved by triangle sum theorem. So for example, the measure of angle 1 will equal 180 degrees minus the 47 minus the measure of angle 2. Notice I'm showing you a different way to solve this here, a different way to write this. Still going to get the same thing, right? 180 minus 47 minus 71, that's equal to 62 degrees. Okay. What else? If I know the measure of angle 1 is 62 degrees, and its alternate interior is angle 8 down here, then I know the measure of angle 8 is 62 degrees. Let's clean some stuff up in here. This is getting a little messy at this point. So here's the ones we're left with. Angle 4 and angle 6. Let's solve for angle 6. Angle 6 is going to be... Oops, sorry. Didn't mean to write that degrees just yet. Measure of angle 6 is going to be the 180 minus angle 5, which is 109, minus the 42, so I got 180 minus 109 minus 42. That's 29 degrees. 29 degrees, where does that go? Right there. So that's done. And then the measure of angle 4 is going to be 180 minus that 109, which is angle 3, minus the 36. That's 180 minus 109 minus 36. That is 35 degrees. All right. Okay. If you want to, you can go back and check and see there's 4 triangles in here. You can add up all the angles. You know that you'll get 180 in each triangle if you did it correctly. If not, then, well, you know, you'd have to try some other method. All right, I think we got 2 more. 2 more that I really want to, 3 more. Okay, sorry, 3. Let's look at 14. 14, we got to solve for x, okay? This angle out here, this exterior angle, is 18x minus 15. We know the 2 non-adjacent angles, which are these circled ones right here. We know if we add those up, we'll get the exterior angle. So let's set up that equation. All right. Let's combine like terms on both sides. And then let's get our subtraction going on. 18x minus 17x is equal to just 1x. If I add 15 to that negative 10 over there, I'm going to get 5. Okay, so x is going to equal 5. And then I want to know these angles. Okay, so what's the measure of angle cab? Well, cab is right here. It's formed by the vertices C, A, and B. So it's this lovely thing. If I'm gonna highlight in orange, might as well do it in orange. Okay. (13 times 5 minus 11). So you get 65 minus 11. You get 54 degrees. Okay, what about ABC? ABC is this one. Let's highlight in a different color. Let's do this blue. ABC is this one right here. So triangle ABC (4 times 5 plus 1). That's 20 plus 1. The measure of angle ABC is equal to 21 degrees. Okay? Let's look here. Angle ABC, or sorry, angle ACB is this one. Which I don't have an expression for. However, I do know that these angles in here, I already know those measures. Okay, 54, 21. So if I just add those together, the 54 and the 21, I'll get the measure of angle ACB. Spilling into another problem. It's all good. Measure of angle ACB is going to equal 180 degrees minus the 54 degrees minus that 21 degrees. That's going to get us 180 minus 54 minus 21. It's 105 degrees. And then we know the measure of angle. Let's get a new color. Let's do this purple. Let's erase everything else too, by the way. The measure of angle DCB, which is right here, given by the expression 18x minus 15. Let's just plug and chug. It's equal to 75 degrees. Which makes sense because we know that these two angles right here, they have to be supplementary because they form a linear pair. 105 plus 75 equals 180. So boom, I know I did my problem right. I'm good to go. All right. I'm actually probably only going to do one more just because I'm getting a little anxious that my software is going to crash like it did the last time. So let's do 7. 7 looks the most daunting. All right. All right, here's what I got. Well, I got some parallel lines. So I know I have some relationships here, like alternate interior or maybe same side interior, things of that nature. And I want to solve for actually x and y. All right. And so here's the thing. Here, there's an expression for x right here. There's an expression for x right here. And if you look between these two parallel lines, this angle and this angle, so look that I encompassed both of them, those, are they on the same side of the transversal? Yes, they are. So they're same side interior angles. And we know that same side interior angles are supplementary. So we know if we add them all together, we'll get 180, okay? So let's do that. Plus 63 degrees plus the 5x minus 8 degrees. That's going to get us a nice 180, okay? Let's add our x's together. 7 plus 5 gets us 12x. Negative 31 plus 68. Subtract an 8 from that, I get 29. Let me just make sure I did my math correctly. Yeah, see, I didn't. I did not. Okay. 63 minus 31 minus 8. It's supposed to be 24. My apologies, guys. 12x equals 180 minus 24. That's 156. Divide 12 on both sides. Fingers crossed. Yeah, we got a nice number 13. Okay. Let's examine here now. So we know what x is equal to. We want to know what y is equal to. This angle right here is y. Or sorry, it has a y in it. And let me erase all this other crap. And we know that it is alternate interior to these lines as well. So we know that if we set them equal to, no, we cannot set them equal to each other. We say that if we add these two together, because they are same side interior, if we add them together, we will get 180 degrees. All right, let's substitute in that 13. So let's do 5 times 13 to get a 65. Let's group all our numbers together. 65 minus 8 plus that 27 is 84. Subtract that 84 on both sides from that 180. Get 96. And then we end with the result that y, once we divide by 4, is equal to 24. Bam. All right. So hopefully you can see that these problems require some background knowledge, which you have. And if you struggle, just remember, I'm always here to help. All right? Take care.